In this video, we're going to start talking about word problems that are solved by using systems of equations. And this is section 4.4 in your book. And this section, I actually will be recording 2 videos. So this is part 1. And before we get going on the word problems themselves, here are some problems that should be reviewed based on things we did in chapter 2. So let's get these done here. It says, what is the formula for the perimeter of a rectangle? So if you said perimeter equals 2 lengths plus 2 widths, you're absolutely right. That would be a rectangle, and these are the 2 lengths, and here are your 2 widths, and perimeter is when you add all 4 sides around a rectangle. Okay, so that's number 1. Number 2 says, at $12.95 per pound, what is the value of 3 pounds of crab legs? Well, if you're buying 3 pounds and each pound is $12.95, then you know you're going to have to multiply. So that'll be 3 pounds times $12.95. And so now this is a calculator problem here. So 12.95 times 3. So $38.85 for the crab legs. Okay, $38.85. Don't forget your units. Okay, find the amount of interest earned by $55,000 invested at a 4% annual simple interest rate for 1 year. So remember that interest, simple interest, so this is number 3. Let's put it here. Interest is equal to principal times rate times time. So the $55,000, that's your principal. The 4% is your rate, and you want that as a decimal. So that's 4/100ths. And the time is 1 year. T equals 1. So then substitute in here, and you get 55,000 times the rate times the time. And so that's equal to times the rate times the time, $2,200. So $2,200 is the interest earned by your $55,000 investment. Okay, number 4, at 35 miles per hour, how far will a Canada goose travel in 12 hours? So the goose is traveling at a rate of 35 miles per hour. So that's your rate, 35. The time is 12 hours, and we're trying to solve for distance. And we're going to use the distance equals rate times time formula. So go ahead and put in your rate, 35, times your time, which is 12 hours. That's going to give us distance in miles. $420 miles. So 420 miles. Okay, that's number 4. Number 5 says a 12-ounce mixture of window cleaner is 8% alcohol. How many ounces of the mixture is alcohol? So this window cleaner has 12 ounces total, but 8% of that is alcohol. So to find how many ounces is alcohol, you're going to find 8% of 12. So the alcohol, this is number 5, means equals 8%. Let's put that as a decimal of, which is multiplication of 12. So then we go ahead and multiply that. and we get that 0.96 of an ounce is alcohol. Okay, so those were the warm-up problems. We're going to be using pieces of these problems in our word problems in this section. So let's do a quick reminder of our problem-solving strategy. After you read your problem, your word problem, you want to analyze the problem. Read it carefully to understand what's given. And list it if you can. What information is given? What are you asked to find? What vocabulary is given? And sometimes you can use a diagram or a table to help you understand the facts of the problem. So that's the first step to analyze. Second, we're going to assign variables to represent unknowns, unknown values in the problem. And so for us, in this section, we're going to have two unknowns. So we'll be using two variables, and usually we will use x as one of the unknowns and y as the other. And you want to make sure you assign those, you actually have statements that say let x equal and let y equal, so that your reader knows what your variables represent. Number 3, you want to form a system of equations by translating the words of the problem into mathematical symbols. So we want to form an equation. And then we're going to solve the system by using our graphing, substitution, or elimination. Actually, mostly we'll be using substitution and elimination because those are algebraic and we can solve for x and y precisely with those. And then number 5, state the conclusion clearly and make sure that you include the units. And then you should check the results, okay? Or at least make sure that your answers make sense in the problem. All right, so here's our first example. Each year, Academy Award winners are presented with Oscars. The 13.5-inch statuette has a base on which a gold-plated figure stands. The figure itself is 7.5 inches taller than its base. Find the height of the figure and the height of the base. So let's analyze the information that's given. Let's define this problem. And so we want to find the height. This statue has two parts to it, doesn't it? It has a base, this dark base, and then it's got the gold statue together. And together, then this is your statuette. Okay? So we want to find how tall this base is, this dark base, and then we also want to find how tall this gold statue part is. Okay? So that's the problem in a sentence. Find how tall the base is and how tall the gold statue is, given that the statue is 7.5 inches taller than the base, and that the entire statuette, that the entire award, or Oscar award, is 13.5 inches. Okay, so that's what we know. And so let's describe how we're going to solve the problem. Well, we are going to assign two variables, one for the height and one for the base. And based on our picture that we have here, we're going to let y be the height of the base and x be the height of the gold statue. And then we're going to come up with two equations using x and y. And then we will be solving the system of equations by using either substitution or elimination. Okay, so that's what we're going to do. So let's go ahead and assign those variables. So let x be the height in inches of the gold statue part. And then we're going to let y be the height in inches of the base. And then we need some equations. So what do we know? Well, we know that the statue is 7.5 inches taller than the base. So the goal statue, which is x, that's the bigger number. And so the statue is, that means equals, 7.5 inches taller. So add 7.5 inches to the height of the base, and that's our y, isn't it? Okay, so that's one equation, that the statue is 7.5 inches taller than the base. The other thing we know is that the award is the two parts together total to 13.5 inches. So the statue plus the base equals 13.5 inches. So now there we have our system of equations, and we want to solve them. And so this is really prime for the substitution method because we have one of our equations already solved. We've already isolated the variable, right? It's for x. So here's our little table that helps us with this. And we are going to replace the x over here with this 7.5 plus y. Okay. So put a parenthesis where x is. There's my equation without x, and now I'm going to substitute. Let's put in a different color. So we're going to substitute this expression here where the x was, so 7.5 plus y. Okay, and now we're going to add the like terms on the left-hand side. So we get 7.5 plus 2y equals 13.5. Subtract 7.5. So 2y equals, and this is going to be 6. And then we're going to divide by 2. So y equals 3. So what have we found? We found 3 inches, that the base is 3 inches. And now we need to find x, and so x is 7.5 inches more than the base. You see that? So substitute x equals 7.5 plus y, so 10.5 inches. So let's state the conclusion here. Let's write the conclusion. The height of the base is 3 inches, and the height of the statue, of the gold part, is 10.5 inches. And are these reasonable answers? Yes, they are, because they add up to 13.5. You can see that 3 plus 10.5 is 13.5 inches, which was the total value of the Oscar. And this gold statue is 7.5 inches more than the base. So yes, they are. So we've checked it by words, but you could substitute in to get the numbers. Okay? All right, here's our next problem. This one is, these are systems to solve geometry problems. So we're going to remind you some vocabulary words. So two angles are said to be complementary if the sum of their measures is 90 degrees. So see here, there's a picture. You've got a 70-degree angle here and a 20-degree angle here. And when you add them together, you get 90 degrees. So we call these angles complementary angles. They add up to 90 degrees. Supplementary angles are two angles that add up to 180. They make a straight angle like this. And so here we have a 30-degree angle and we have a 150-degree angle, and together they add up to 180. So those are called supplementary angles. Okay, so let's look at the next example. It says the difference of the measures of two complementary angles is 6 degrees. Find the measure of each angle. So let's define the problem in a sentence. So we have two angles. They're that are complementary. And one angle is 6 degrees larger than the other. Because that's what it means to say that the difference of the measures is 6 degrees. So one angle, the large angle minus the smaller angle equals 6 degrees. Large angle minus small angle equals 6 degrees. Okay, the difference. All right, so how are we going to solve this problem? Well, again, we're going to use a system of equations with two unknowns. Okay, system of equation with two unknowns. So let's define those unknowns. So let's let x be the smaller angle, and let's y be the larger. How's that? Larger angle, okay? And so what do we know about these two angles? Well, first of all, they're complementary. Remember, they're complementary, and what does that mean? That means that they add up to 90 degrees. So the small angle, so we have kind of a picture like this. Okay, we have x, which is smaller, y is bigger, and together they add up to 90 degrees, so they're complementary. And then the other thing we know is that the large angle minus the small angle is 6 degrees. So we said what? Y was the larger, so y minus x is 6 degrees. Okay, so I'm looking at these two, and if I rearrange this, then we will have a nice system for elimination method. So let's rewrite the system down here, and I'm going to rearrange the 2, then put the negative x plus y here, and now we've got the opposites that we need here for coefficients so that we can use elimination method. So let's use elimination method. We're going to add these. The x's cancel, that's 0, and here we get 2y. And then here we get 96, and then we're going to divide by 2. So y equals 48 degrees. So that's one angle. And then the other angle, well, we know that x plus 48 degrees equals 90, right? Because we know that the two angles add up to 90. So let's subtract the 48 from the 90 degrees. And that's going to give us the other angle. And so the conclusion is that the two angles are 42 degrees and 48 degrees. And are the answers reasonable? Yes, these two angles add up to 90, and this large angle minus this small one does give us 6 degrees. So this checks. Okay, next. History, it says, in 1917, James Montgomery Flagg created the classic I Want You poster to help recruiting for World War I. The perimeter of the poster is 114 inches and its length is 9 inches less than twice its width. Find the length and the width of the poster. Okay, so here's our poster, and here's the length L and the width W. And so the problem is that we know that this length is 9 inches less than twice this width. We know the total perimeter. The total perimeter is 114 inches. And we want to find the length and the width. Okay, so how do we plan to solve this problem? We'll define the two variables, L for length and W for width, and then we're going to create a system of equations, okay, to solve. So let's do that. So let's let L equal the length of the poster, and let's let W represent the width of the poster. And so we know the perimeter is 114 inches. So perimeter we know is 2 lengths plus 2 widths. So 114 is equal to 2 lengths plus 2 widths. So there's one equation. Then the other equation we have is that the length is 9 inches less than twice the width. Length, that's L, means equals 9 inches less than. So less than changes the order. So we're going to put a subtraction. And so it's 9 inches less than, and it was what, twice the width? And it was less than twice the width. So 2W. Okay, so L equals 2W minus 9. So there's one equation, and here's the other equation. Here's our system. And you can see that these are all set again for substitution method. So let's put our one equation here already where we've already isolated the L. And then here's our other equation. And we are going to replace L. So put a parenthesis. Rewrite your equation, put a parenthesis, and then we're going to substitute this 2W minus 9. That's going to come over here where L is. 2W minus 9, because we've substituted it from the equation on the left. So now we simplify. We'll have to distribute here with the 2. We get 4W minus 18 plus 2W. And so then just go ahead and add the like terms. So 114 equals 6W minus 18. And we're going to add 18 to both sides. So now we get 132 equals 6W. And we're going to divide by 6. So then we have divide both sides by 6, so this will be 22. It's 22 inches for the width, and then we want to go ahead and substitute that 22 up here into our L equals 2 times 22 minus 9, which is 44 minus 9. Let's see, so we get 35 inches. So let's see if that checks. So our poster would have would be 22 for the width, 22 inches and 35 on either side. So let's see what the perimeter would be. 2 times 22 is 44 plus 2 times 35 is 70. So that's definitely going to be 114 inches, which we got before. And twice the width, 2 times the width is 44. And 44 subtract 9 is our 35. So the length is twice the width minus 9, so that checks as well. Good. Okay, in example 3, we have at a school 2 picture packages are available as shown in the illustration. So find the cost of one class picture and the cost of an individual wallet-sized picture. So we've got these 2 packages. In analyzing the information, we've got package 1, which has 1 class picture plus 10 wallet size, and that's $19. And then package 2, which has 2 class pictures and 15 wallet size, and that's $31 each. Okay, so that's what's given. And so let's let, we want to find the cost of the class picture and of 1 wallet size picture. So let's define 2 variables. Let's let, let's call C. Let's let C be the cost of 1 class size picture, or class picture, sorry, 1 class picture. And then let's W be the cost of 1 wallet picture, okay? And the 2 equations, because we're going to set up a system again, it's almost given right here. You can almost see the equations right up here. That 1 class picture, so C plus 10 wallets equals 19, and 2 class pictures plus 15 wallets equals $31. So this one we can use either substitution or elimination. It's going to be your choice. Let's see, why don't we use elimination, and we'll eliminate the C's. And we need these to be opposites. So this is a 2, so if we can make this a negative 2C, then we'll be all set. So we're going to multiply by negative 2 this entire row. Negative 2C plus, negative 20W equals negative 38. Then this one can be unchanged, so just rewrite it right underneath. And then we're going to add, and that cancels these. And so we have negative 5W equals negative 7. That's what it's looking like. I'm going to divide by -5. And so W equals, let's see, 5 into 7 once, 2 left over. So $1.40 for the wallet size. We got that the wallet size is 40. Okay, so now we need to solve for C. So let's substitute the 140 up here in this first equation. So C plus 10 times $1.40 equals 19, and we will solve for C. So this 10 times would be 14, and then subtract 14, and it looks like the cost of the class size picture is $5. It's $5. So let's check our answers here. So one wallet size costs $1.40. One class picture costs $5. So let's see, can we check our answers? Let's check it back up here and let's see. So one class picture, which is $5, plus 10 wallet size, that's $14. So that equals 19. So that checks. Two class pictures, 2 times 5 is $10, plus 15 times $1.40. Let's see what that is. Where's my calculator? 15 times $1.40, $21. So good. 10 plus 21 equals 31. So that checks as well. Excellent. Okay, now go to part 2 for the next video.